Download this code from codegive.com, link in the description below. OK, let's dive into the realm of bad code and how it relates to GitHub topics and GitHub in general. This will be a comprehensive guide, covering what constitutes bad code, why it's problematic, examples, and how GitHub can both contribute to and help mitigate these issues. Defining bad code, a multifaceted problem. Bad code isn't a single, easily definable entity. It's more of a spectrum of qualities that make code difficult to understand, maintain, debug, and extend. Here's a breakdown of the most common characteristics. Lack of readability. This is paramount. Code should be easily understandable, even by someone who isn't intimately familiar with the code base. Factors contributing to poor readability. Poor naming. Variables, functions, and classes should have descriptive names that clearly indicate their purpose. X, Y, foo, data, without context, are often poor choices. Excessive complexity. Functions or methods that are too long, have too many nested loops / conditionals, or perform too many unrelated tasks. This is often referred to as God classes or God functions. Lack of comments. While comments shouldn't be a substitute for well-written code, they're crucial for explaining complex logic, intentions, and edge cases. Especially important for code that can't be easily understood just by reading it. Inconsistent formatting. Inconsistent indentation, spacing, or capitalization can make code visually jarring and harder to parse. Magic numbers / strings. Using literal values directly in the code without explanation. For example, if age 18 is fine. If status code equals 200 is fine. If status code equals 199 is bad without commenting why. Boolean blindness. Passing true / false without using an enum or meaningful variable, making it difficult to see what each state represents. Poor maintainability. Code should be designed in a way that makes it easy to modify, fix bugs, and add new features without introducing unintended consequences. Indicators of poor maintainability. Tight coupling. Components are highly dependent on each other, making it difficult to change one part of the system without affecting others. Lack of modularity. Code is not broken down into reusable components, leading to duplication and increased complexity. Technical debt. Making compromises in code quality to meet short-term deadlines, creating future problems. Poor performance. Code that runs inefficiently, consuming excessive resources, CPU, memory, network bandwidth, or taking a long time to execute. Inefficient algorithms. Using inefficient algorithms or data structures for the task at hand, example searching a large array when a hash table would be much faster. Unnecessary I/O. Performing unnecessary disk reads / writes or network requests. Memory leaks. Failing to release allocated memory, leading to resource exhaustion. Premature optimization. Optimizing before profiling, or optimizing without considering the human effort it might take. Lack of error handling. Code that doesn't properly handle errors, leading to crashes, unexpected behavior, or security vulnerabilities. Ignoring exceptions. Catching exceptions and doing nothing with them. Unclear error messages. Providing unhelpful or misleading error messages that make it difficult to diagnose problems. No input validation. Failing to validate user input, opening the door to security vulnerabilities like SQL injection or cross-site scripting, XSS. Lack of testing. Code that isn't adequately tested, making it difficult to verify its correctness and prevent regressions. Asterisk no unit tests. Asterisk lack of tests that verify individual components of the code. Asterisk insufficient test coverage. Asterisk not testing all possible scenarios and edge cases. Asterisk flaky tests. Asterisk tests that sometimes fail even when the underlying code is correct. Asterisk security vulnerabilities. Asterisk code that exposes the system to security risks. Asterisk SQL injection. Asterisk allowing attackers to execute arbitrary SQL commands. Asterisk cross-site scripting, XSS allowing attackers to inject malicious scripts into web pages. Asterisk buffer overflows. Asterisk writing beyond the bounds of a buffer, potentially overwriting critical data or executing malicious code. Asterisk hard-coded credentials. Asterisk storing passwords or API keys directly in the code. Asterisk violations of design principles. Asterisk code that violates established software design principles, making it difficult to reason about and maintain. Asterisk single responsibility principle, SRP. A class or module should have only one reason to change. Asterisk open/closed principle, OCP. Software entities should be open for extension but closed for modification. Asterisk Liskov substitution principle, LSP. Subtypes should be substitutable for their base types without altering the correctness of the program. Asterisk interface segregation principle, ISP. Clients should not be forced to depend on methods they do not use. Asterisk dependency inversion principle, DIP. High-level modules should not depend on low-level modules. Both should depend on abstractions. Abstractions should not depend upon details. Details should depend upon abstractions. Asterisk dead code. Asterisk code that is never executed, either because it's unreachable or because it's been commented out and never removed. It clutters the code base and can lead to confusion. Asterisk duplicated code. Asterisk repeating the same code in multiple places. This makes it harder to maintain because you have to update the code in every location where it's duplicated. 2. Examples of bad code, with github specific context. Let's look at some examples of bad code, with a focus on how they might appear in a GitHub repository. 1. Poor naming and lack of comments. Problem asterisk it's impossible to understand the purpose of the function or variables without diving into the implementation. Someone looking at this code on GitHub would have no clue what X, Y, A, B, or C represent. Better asterisk. GitHub context asterisk when browsing code on GitHub, clear naming and comments are vital for understanding the project quickly. Good documentation, readme.md, comments, significantly improves the accessibility of the code. 2. Excessive complexity, God function. Problem asterisk this process order method is doing far too much. It's difficult to understand, debug, and maintain. Any change to one part of the process could break other parts. Better asterisk use the single responsibility principle. Break the method into smaller, more focused methods or classes. GitHub context asterisk large, monolithic files make it difficult to review code changes on GitHub. It's harder to identify the specific lines that have been modified and understand their impact. Smaller files promote better code review. 3. Lack of error handling. Problem asterisk this code lacks any error handling. If the fetch request fails, the response is not valid JSON, or my data is null, the code will crash. Better asterisk. GitHub context asterisk error handling is critical for reliability. When others pull and run the code, it will not crash when network glitches occur, and they will know what went wrong. A good example can prevent issues for anyone using the code. Continuous integration, CI, systems often use error handling to report build failures. 4. Security vulnerabilities, SQL injection. Problem asterisk this code is highly vulnerable to SQL injection. An attacker can inject malicious SQL code into the username or password fields to bypass authentication or steal data. Better asterisk use prepared statements with parameterized queries. GitHub context asterisk security vulnerabilities are a major concern. Public repositories are scanned for known vulnerabilities. If vulnerabilities are found, GitHub may notify the repository owner. Reviewing security-sensitive code carefully is crucial. If you are not familiar with security aspects, ask for security reviews. 5. Duplicated code. Problem asterisk the logic for calculating the area of a square is the same as calculating the area of a rectangle where the length and width are equal. This leads to code duplication. Better asterisk. GitHub context asterisk duplicated code makes it harder to maintain the code base. When changes are required, you need to remember to apply them in multiple locations. It also increases the overall size of the repository. 3. GitHub topics and bad code. GitHub topics are keywords associated with repositories that help users discover projects related to specific areas. While there isn't a single bad code topic, several topics are relevant. Refactoring is the process of improving the internal structure of code without changing its external behavior. Repositories tagged with refactoring often contain tools, techniques, or examples of refactoring bad code. Code smell. Code smells are indicators that there might be deeper problems in the code. Repositories tagged with code smell may contain linters, static analysis tools, or guides for identifying and addressing code smells. Static analysis tools analyze code without executing it to find potential bugs, security vulnerabilities, or code style violations. These tools can help detect bad code. Linter. Linters are a type of static analysis tool that enforce coding standards and identify potential errors. Code review. Code review is a process where developers review each other's code to find bugs, improve code quality, and share knowledge. Repositories tagged with code review might offer tools, guidelines, or workflows for effective code review. Testing. Thorough testing can expose many problems in the code. Repositories with testing as a tag will show testing methods, frameworks, and best practices. Example of using GitHub topics to find tools. Let's say you want to find a static analysis tool for your Python project. You could search GitHub for repositories tagged with Python and static analysis. This will help you discover tools like Pylint, Flake8, or MYPY. 4. How GitHub can contribute to, and mitigate, bad code. How GitHub can contribute to bad code, unintentionally. Lack of standards. If a GitHub repository doesn't have clear coding standards or guidelines, it's more likely to accumulate bad code. Ignoring code reviews. Skipping or rushing through code reviews can allow bad code to slip into the code base. Pushing code too quickly. Rushing to push code without proper testing or refactoring can lead to technical debt. Lack of collaboration. If developers don't communicate effectively, they might create conflicting or redundant code. Over-reliance on quick fixes. Trying to solve a problem without considering the long-term implications. How GitHub helps mitigate bad code. Code reviews. GitHub's pull request feature facilitates code reviews. Developers can submit changes for review, and other contributors can provide feedback before the code is merged. Continuous integration. CI GitHub Actions allows you to automate code testing and analysis. You can set up CI workflows that run linters, unit tests, and other checks whenever code is pushed to the repository. Code owners. GitHub allows you to define code owners for specific files or directories. This ensures that changes to those areas are reviewed by the appropriate experts. Issue tracking. GitHub's issue tracker allows you to report bugs, request features, and discuss code improvements. GitHub discussions. A dedicated space for developers to collaborate and ask questions about the code. GitHub Copilot, AI pair programmer. While a new tool, Copilot can help suggest better code, potentially avoiding some bad habits in the first place, but use it critically and review its suggestions. GitHub Advanced Security. This offers features such as secret scanning, identifies exposed credentials, and dependency scanning, detects vulnerabilities in dependencies. GitHub's CodeQL** provides query languages that allow developers to find patterns in code that might indicate vulnerabilities. Code example demonstrating improvement with GitHub. Let's imagine a scenario where a small team is working on a Python script to process customer orders. Initial state, bad code. This code is hard to read, no comments, cryptic variable names. Prone to errors, no validation of order_data. Not modular, does everything in one function. Difficult to test. Workflow using GitHub to improve the code. 1. Create a GitHub repository. The team creates a repository for the project. 2. Initial commit. The initial version of order_processor.py is committed to the repository. 3. Create an issue. A team member creates an issue in GitHub to track the need to refactor the code and add unit tests. The issue title might be Refactor Order Processing Script for Readability and Testability. 4. Create a branch. A developer creates a new branch, example Refactor Order Processing, to work on the improvements. 5. Refactoring and unit testing. The developer refactors the code to use descriptive function and variable names. Break the code into smaller, more manageable functions. Add error handling, validation. Add unit tests. 6. Commit and push changes. The developer commits the changes to the refactor order processing branch and pushes it to the GitHub repository. 7. Create a pull request. The developer creates a pull request, PR, from the refactor order processing branch to the main branch. The PR includes a description of the changes and links to the issue. 8. Code review. Other team members review the code in the PR, providing feedback on code style, test coverage, and potential issues. They can use GitHub's commenting feature to discuss specific lines of code. 9. Address feedback. The developer addresses the feedback from the code review, making further improvements to the code and tests. They commit and push the changes to the refactor order processing branch. GitHub automatically updates the PR with the new changes. 10. Merge pull request. Once the code review is complete and all issues are addressed, the PR is merged into the main branch. The issue is closed. 11. Continuous integration, CI. The CI workflow runs the unit tests automatically whenever code is pushed to the repository. If the tests fail, the CI workflow will report an error, preventing the bad code from being merged. 6. Best practices to prevent bad code in GitHub projects. Establish coding standards. Define clear coding standards and style guides, example using PEP 8 for Python, for the project. Use linters to enforce these standards automatically. Use static analysis tools. Integrate static analysis tools into your CI/CD pipeline to detect potential bugs and code smells. * write unit tests * write unit tests to verify the correctness of your code. Aim for high test coverage. * conduct thorough code reviews * make code reviews a mandatory part of your workflow. Encourage reviewers to be critical and provide constructive feedback. * use Git effectively * use branches for development, and create pull requests for code reviews. Write clear commit messages that explain the purpose of each change. * follow design principles * adhere to established software design principles, SRP, OCP, LSP, ISP, DIP. * continuous integration, CI set up a CI pipeline that runs linters, tests, and other checks automatically whenever code is pushed to the repository. Automated security scanning enable automated security scanning to detect vulnerabilities in your code and dependencies. Document your code write clear and concise documentation for your code. Use comments to explain complex logic and edge cases. Regular refactoring schedule regular refactoring sessions to improve the internal structure of your code. Address technical debt proactively. Educate your team provide training and mentorship to help team members improve their coding skills. Set up code owners assign code owners to specific parts of the code to ensure knowledge and responsibility. Version control everything store everything in version control. This allows you to revert to previous versions of your code if something goes wrong. Regular backups ensure you have backups of your code. While GitHub provides some redundancy, it's always a good idea to have your own backups. Update dependencies regularly keep your dependencies up to date to address security vulnerabilities and bug fixes. Use a dependency management tool use a dependency management tool, example npm, pip, maven, to manage your project's dependencies. 7. Conclusion. Bad code is a significant problem in software development. GitHub provides a platform for collaboration and code management, and by adopting best practices for coding, code review, testing, and continuous integration, you can significantly reduce the amount of bad code in your projects. Remember that code quality is a continuous process, not a one-time fix. By making code quality a priority, you can improve the maintainability, reliability, and security of your software.